Let's practice evaluating algebraic expressions together. In each of these given expressions, we're going to say that x is equal to 4 and that y is equal to 2. Okay, so we're going to use those for our values for x and y and make those substitutions. So for number 1, we have this expression of 2x plus 7. Remember, this means 2 times whatever x is, and we know x is 4, and then we're going to add on 7 afterwards. So we're going to go ahead and write 2 multiplied by this 4. And so when we go ahead and do that, let's use parentheses to show that substitution and multiplication. Then we're going to add on 7 afterwards. Okay. Now multiplication is going to come before addition here. So 2 times 4, that's going to be 8. So it's going to be 8 plus 7. And then we just have one thing to do here, and 8 plus 7, that's going to equal 15. All right, so that would be the value of this expression if x is equal to 4 and y is equal to 2, but we didn't have to use the y here. Okay, so let's check out number 2. For number 2, we have this expression of 18 minus 5y. Now we see here that y is equal to 2, so let's make that substitution. So we're going to take 18, we're going to subtract the product of 5 and whatever y is. Now we know y is equal to 2, so let's make that substitution. Now we have two things to do here. We have subtraction and multiplication. Multiplication is going to get to go first here according to the order of operations. So 5 times 2 is 10, so we're going to have 18 minus 10. And 18 minus 10 is just equal to 8. So that would be the value of this expression if y was equal to 2. All right, for number 3, we have this expression of negative 9, and we're going to be taking away 5x. So let's go ahead and take this negative 9 and take away 5 multiplied by whatever x is. Now remember, x was equal to 4, so you can look up at the top over there as well to see that if you forgot it. And so between subtraction and multiplication here, multiplication is going to go first. So we're going to say 5 times 4 is equal to 20. So we're going to have negative 9. And instead of saying minus 20, I'm going to go ahead and write plus a negative 20. Okay, since that's the same thing, we're just going to add the opposite instead, and that's the same value. Again, I kind of did two things here. I multiplied 5 and 4, but I also turned the subtraction problem into adding the opposite, which is the same thing. We're going to get you the same value. So here it's a little bit easier for me at least, and a lot of other people I hope. Negative 9 plus negative 20, that's going to equal negative 29. All right, that would be the value of this expression if x was equal to 4. For number 4, we have this expression of xy subtracting 5x. So that means x times y minus 5 times whatever x is. So x, let's make that substitution, we know is equal to 4. And y, we know that value is equal to 2. That's what we're given for this expression. Then we're going to go ahead and take away 5 times whatever x is. Now remember, x we said was equal to 4. So we have two 4s in this problem just because there were two locations where x showed up. We have 3 operations here. We have multiplication over here on the left. We have subtraction and multiplication again. We have 2 multiplications. Let's just do the one on the left here. So 4 times 2, that's going to equal 8. So we have 8 minus 5 times whatever 4 is. Okay. Then we're going to go ahead and use this multiplication over here. 5 times 4, that's equal to 20. So we really have 8 take away 20. Now 8 minus 20 is the same thing as 20 minus 8. Just make it negative. So if we do 8 minus 20, that should be negative 12. So that would be the values of this expression if x was equal to 4 and y was equal to 2. Here's number 5. For number 5, we have this expression of negative 5x plus 8y. So it's negative 5 times whatever x is plus 8 times whatever y is. So let's go ahead and make some substitutions. So this is negative 5. That's going to multiply by x. Now we know x is equal to 4. So let's change that to a 4 plus 8 times whatever y is. Now we know y is equal to positive 2. Let's make that substitution right over here. We have 3 operations. We have multiplication, addition, and multiplication. Let's just go from left to right, even though we have 2 multiplications. The one on the left goes first. Negative 5 times 4 is going to equal negative 20 plus this 8 times this 2. Now between addition and multiplication, we're definitely going to do multiplication here first. So 8 times 2 is 16. So we have negative 20 plus 16, and then finally negative 20 plus 16 is going to equal negative 4. So this would be the value of the expression. For number 6, we have this negative 5x plus y cubed. So it's negative 5 times whatever x is plus whatever y is cubed. So making some substitutions, we have negative 5, that's going to multiply by x. We know x is equal to 4. Let's make that substitution. And then we're going to add on this y here. Now y is equal to 2. Let's go ahead and plug that 2 in, and let's go ahead and cube that. Okay, so we have three operations here. Looks like we have multiplication, addition, and a power. Now the power is going to get to go first here, so 2 cubed. Now remember, 2 cubed is equal to 8, right? So I'll write that on the side here. But 2 to the third power, that's equal to 2 times 2 times 2. And so 2 times 2 is 4, 4 times 2 is equal to 8. All right, so let's go ahead and rewrite this. It's negative 5 times 4, and then plus 8. Now between multiplication and addition, let's go ahead and do this multiplication here. So negative 5 times 4 is negative 20, and then negative 20 plus 8, that should still be negative, right? That's going to be negative 12. That would be the value here. All right, for number 7, looks like we have a little bit longer of an expression, and we have a grouping symbol as well. So we have 3 times the quantity of negative 5 plus x plus the product of x and y, or x times y. So let's start with some substitution. So this is going to be 3 times the quantity of negative 5 plus x. Now we know x is equal to 4, so let's go ahead and just write that in. When we make that substitution, it's just good to put those in parentheses. And then we're going to go ahead and add x times y. Now x we said was equal to 4, so it's 4 times y, which is equal to 2. Okay, according to the order of operations, we're going to do what's inside this grouping symbol first. Okay, so that's negative 5 plus 4. Negative 5 plus 4 is going to equal negative 1. So we have 3 multiplied by negative 1 plus the product of 4 and 2. Now, we don't really need the parentheses here if we don't want them, so I'm just going to drop them right now. It's a little bit less writing right now. We don't have any decimals or fractions, and they're both positive numbers. Okay. We have 3 operations. We have multiplication, addition, and multiplication. Let's just go from left to right between the 2 multiplications. So 3 times negative 1 is equal to negative 3. We have negative 3 plus the product of 4 and 2, or 4 times 2. Multiplication is going to go next here. We have negative 3 plus, and then 4 times 2 is equal to 8. And then finally, the sum of negative 3 and 8, or adding these two together, we're going to get positive 5. That would be the value of this expression if x was equal to 4 and y was equal to 2. For number 8 here, we have this expression where we have negative 2 times x plus 8 times the quantity of negative x plus 7. So let's go ahead and make some substitutions here. So it's negative 2 multiplied by x. We're given that x is 4, so let's go ahead and substitute that in. Plus 8 times the quantity of, and I'm going to use brackets here just because we have parentheses already. And what's going to be inside here is going to be a negative x. Now x here is going to be what? X is going to be 4, like we just said a moment ago, and then we're going to go ahead and add 7 afterwards. Okay, so feel free to use parentheses too. I'm just using brackets to make it a little bit more clear if there's already parentheses that we see here. Okay, so following the order of operations, let's look inside the grouping symbol. Inside the grouping symbol, we see we have a negative multiplied by a 4, or a negative 4. There's really a negative 1 in front of that 4 being multiplied. So I'm just going to go ahead and write this step down. I can totally see people just using maybe one step and skipping this one and just adding what's inside there, and that's fine as well. So this is going to be 8 times, and I'm going to change these back to parentheses. This is really going to be negative 4 plus 7. Okay, so didn't really do too much there, but just showing that that negative 4, or the opposite of 4, is negative 4. Okay. Again, if you jump to this step here, that's fine too. Let's go to negative 4 plus 7. That's going to equal 3, right? So we have negative 2 multiplied by 4. Changing that parentheses to a dot because it means the same thing, and this is 8 times 3 because that's a positive 3. Okay, we have 3 operations here. Two of them are multiplication, so let's just go from left to right. Negative 2 times 4 is going to equal negative 8. We have negative 8 plus the product of 8 and 3. Between addition and multiplication, let's go ahead and complete this multiplication. So 8 times 3 is 24, so we have negative 8 plus 24. And then finally, negative 8 plus 24 should definitely bring us to the positives, and that's going to be positive 16. So if x is equal to 4, then this expression would equal 16. Alrighty, now we're going to go ahead and practice some problems where we have some rational values or some fractions here. For this set of 4 problems, we're going to go ahead and evaluate each of these algebraic expressions, which means solve. In this case, x is now equal to 3/4 and y is equal to 1/3. So let's use those values for x and y here so we have some fractions. Okay. So for number 9, we have 12 times x plus 9 times y. So the product of 12 and x plus the product of 9 and y. So let's go ahead and multiply, or substitute rather. 12 is being multiplied by this 3/4. So let's go ahead and write times 3/4. And now we're going to go ahead and add the product of 9 and y. Now y looks like it's 1/3, so let's go ahead and write multiplied by 1/3 here. Okay. Now keep in mind, how do we multiply whole numbers and fractions? Well, 12 is really 12 over 1, right, as a fraction, and multiplied by 3/4. Let's go ahead and write it just like that. Plus 9 as a fraction is 9 over 1, multiplied by 1/3, just like this. Okay, so we have three operations here. We have multiplication, addition, and multiplication. Let's just focus on the multiplication on the left here because it comes first. Now, looks like we can cross cancel here, right? So if we're multiplying, this 4 and 12 can both divide by 4. That's their GCF. So 4 divided by 4 is 1, and 12 divided by 4 is 3. Now, if you multiply 3 times 3 on top, that's 9, and 1 times 1 on bottom is 1. So we're going to get 9 over 1, which is really just 9, right? Now we're going to go ahead and copy the rest of this down. That's 9 plus the product of 9 over 1 and 1 over 3. Now it looks like at this point we should do this multiplication, right? Now we can cross cancel when we're multiplying here. So this 9 and 3 have a GCF of 3. So 9 divided by 3 is 3, and 3 divided by 3 is 1. If you multiply on top, 3 times 1 is 3, and on bottom 1 times 1 is 1. So that's just going to be 3 over 1 or 3. So we're going to have 9 on the left plus 3, and then 9 plus 3 is equal to 12. 12 would be the value of this expression. For number 10, we have this expression of negative 20x plus 18y squared. So this is negative 20. We're going to multiply that by x. Now x is 3/4, so let's go ahead and substitute that in as 3/4. And then we're going to go ahead and add the product of 18 and y squared. So y is 1/3. Let's go ahead and plug in 1/3 here. And we're going to go ahead and square that. Okay, so between these here, it looks like we have multiplication, addition, we have multiplication, and then we have a power at the end here. Out of all of these, the power is going to go first. Now, 1/3 squared, keep in mind 1/3 that as a fraction squared is really equal to 1/3 times 1/3. 1/3 times 1/3 is equal to 1/9. Okay, so that's the value of 1/3 squared. So if we go ahead and copy down the rest of this, this is negative 20. Now for now, I'm just actually going to write negative 20 over 1 times 3 over 4 because I know we're going to have fractions in a little bit. Plus 18, we can rewrite that as 18 over 1 right now. And we figured out that this 1/3 squared was equal to 1/9. So let's just go ahead and swap that out for a 1/9 because those are equivalent or equal to each other. Now we have three operations. We have multiplication, addition, multiplication. Let's go ahead and go from left to right here. Let's go ahead and multiply these two. Looks like we have a GCF we can simplify by, so divide 4 by 4 to get 1, and divide negative 20 by 4 to get negative 5. Okay, so negative 5 times 3 is going to be negative 15 on top, and 1 times 1 is going to be 1 on bottom, so we're going to have negative 15 over 1, or just negative 15. So we have negative 15 plus 18 over 1 times 1 over 9. Okay, now it looks like we can cross cancel for this multiplication problem to the right here, right? So it looks like this 9 and 18 can both divide by 9. So 9 divided by 9 is 1. 18 divided by 9 is going to equal 2. So 2 times 1 on top is 2. 1 times 1 on bottom is 1. So we have 2 over 1, which is just equal to 2. So we're going to have negative 15 plus 2. And now we just have integers, which is kind of nice because we don't have to deal with fractions anymore. Negative 15 plus 2 is equal to negative 13. That would be the value of this expression if x was equal to 3/4 and y was equal to 1/3. For number 11, we have this expression of negative 21y plus 28x. So this is negative 21, and that's going to be multiplying by this y value. Now y is 1/3, so let's go ahead and substitute that in. And we're going to go ahead and add 28 multiplied by whatever x is. Now x is 3/4, so let's go ahead and put that in parentheses. We're going to multiply there. Okay. Now let's go ahead and rewrite these as fractions. So we have negative 21 over 1 multiplied by 1/3. And if you wanted to go straight to this step first, you could have rewritten the whole numbers as fractions over 1 and saved one step if you would like to. I'm just going ahead and trying to write out a couple more steps to make sure it's extra clear of what we're doing. Now we're going to go ahead and do this multiplication to the left first. Looks like we can cross cancel. 3 and 21 can both divide by 3. 3 divided by 3 is 1, and negative 21 divided by 3 is going to be negative 7. So negative 7 times 1 is negative 7. 1 times 1 is 1, so negative 7 over 1 is equal to negative 7. So you can see here that this cross cancels pretty nicely. And we're going to go ahead and add 28 over 1 times 3 over 4. Okay, between addition and multiplication, let's go ahead and do the multiplication. Looks like we can cross cancel. This 4 and 28 both can divide by 4. So 28 divided by 4 is 7, and 4 divided by 4 is 1. So 7 times 3 on top is 21, and 1 times 1 on bottom is 1. So 21 over 1 is still 21. So we can write negative 7 plus 21. And it's nice here, everything cross-canceled, and this is just going to be adding integers. So negative 7 plus 21 is going to equal a positive 14. Okay, here's number 12. For number 12, we have 6y squared plus 6x. So this is going to be 6 times whatever y is squared, but it's just the y that's being squared, right? Not the 6. So this is this 1/3, that's y, and that's being squared. And then plus 6 times whatever x is. Now it looks like x here is equal to 3/4. So let's go ahead and plug in 3/4. Okay, so we have a few different things to do here. We have multiplication, we have a power, we have addition, and we have multiplication. Let's go ahead and complete the power here first. So it's 1/3 squared. We actually already did 1/3 squared over here to the left, so that's equal to 1/9. So I'm going to go ahead and say this is 6 as a fraction of 6 over 1. This is 1/9. And then we're going to add 6 as a fraction, again, is 6 over 1 times 3 over 4. So this last one, this one's not going to cross-cancel as nicely as all the other ones. I just wanted to make sure we could practice our other fraction operations as well, at least one time here. And so we should do the multiplication problem to the left here. And you can see that the 6 and 9 are not going to cross-cancel to make whole numbers, but we can still divide by their GCF. So dividing both of these numbers by 3, 6 divided by 3 is 2, 9 divided by 3 is 3. So on top, 2 times 1 is 2, and on bottom, 1 times 3 is 3. So we're going to end up with 2/3 over here. Okay, so it's still a fraction, and this is totally going to happen sometimes, so just want to make sure you are exposed to it. And so this is going to be 6 over 1 times 3 over 4. And we're going to do this multiplication problem over here to the right. And so it looks like we can cross cancel a little bit. The 6 and 4 can both divide by 2. So 6 divided by 2 is 3, and 4 divided by 2 is going to be 2. So multiplying 3 times 3 on top is 9, and then 1 times 2 on bottom is 2, so that's going to be 9 over 2. So we really have 2 over 3 plus 9 over 2. All right, so if we take a look here, if we want to add these fractions together, we're going to need some common denominators, right? So if we take a look at this 3 and 2, when do they meet for the first time? Well, since they are relatively prime, we can just multiply 3 times 2, and that would equal 6. So they meet together at the first time at 6. So we will, in our kind of heads, hopefully just multiply times 2 times 2. If we rewrite this fraction of 2/3, that would be 4/6. So I'm going to go ahead and write 4 over 6 over here to the right. And then if we want to get 6 on the bottom for this 9 over 2, we should times this by 3 and 3 on top and bottom. If we go ahead and do that, we're going to end up with 27 over 6. So let's go ahead and write plus 27 over 6. Okay, so again, we had this addition problem over here, but they did not have the same denominators, but we did rewrite them equivalent fractions, so they do have the same denominators here. And so we have the same expression here, just written with common denominators. Now that they both have 6 on bottom, we can add this 4 and 27. 4 plus 27, that's going to equal 31. So we have 31 over 6, which could be our final answer. Or we could also write this as a mixed number, which is going to be 5 and 1/6. But either of these would be a completely okay final answer here. Alrighty, here is one final problem. Let's take a look at the directions here. So we're going to now apply our understanding here, apply our knowledge of algebraic expressions. So we've just been dealing with algebraic expressions, and let's answer these following questions. So looks like we are going to a hot chocolate cafe, and we're going to go ahead and take a look at the following menu. So it looks like we have some regular hot chocolate. We're going to call that H. Or if you want to add marshmallows, we'll call that M. Every time you add fudge, that's going to be the variable F. Large hot chocolate B, and caramel is C, and if you want to add a chocolate spoon, we're going to use the variable E to represent that, so we don't have to write out all these long words. Those will be kind of like our legend or our key to knowing what we're talking about. So what are we going to do here? We are going to write an algebraic expression in part A representing the change, okay, so how much money you get back from this hot chocolate cafe. We're going to be paying with a $20 bill. We're going to order 2 of these regular hot chocolates. We're going to order 1 large hot chocolate. Looks like we're going to order 2 of these chocolate spoons to go in these hot chocolates, and we're only going to get 1 serving of fudge. So that's going to be the total order here. So let's go ahead and write an expression showing the change that you're going to receive from them when you pay with this $20 bill for all this food. Let's go ahead and write change received. Okay. And let's see what that's going to be. Well, you're going to pay with the $20 bill, so let's start with that first. That's going to be $20, and then we're going to subtract what you are buying. So it looks like you are buying 2 hot chocolates, right? This 2 regular hot chocolates. So we're going to call those H, and we're buying 2 of them. So we're going to say we're buying 2 of these hot chocolates. So for an algebraic expression, we're just going to say minus 2H. Then it looks like we are buying 1 of these hot chocolates. So hot chocolate is being represented by B. So we can write minus 1B or just minus B, right? By the identity property, we don't have to write that 1. Looks like after that, we're buying 2 of these chocolate spoons. Now each of these chocolate spoons is represented by the variable E. So let's go ahead and subtract the cost of these chocolate spoons, so 2E. And then finally, we're getting 1 serving of fudge here. So fudge, it looks like, is going to be represented by the variable F. So we can write minus 1F or just minus F. Now, another way you could write this expression is you could just take this $20 or 20.00, you could subtract, and you could just write all of this kind of together in parentheses, and you could add up the cost of everything. So that would be 2 of the regular hot chocolates plus 1 of the large hot chocolate, so it's plus B plus 2 times whatever the chocolate spoons are, so it's going to be 2E plus F here. That's going to be the cost of the fudge. So both of these expressions are equivalent to each other. So in this first one, you're just subtracting the cost of each item to see how much change you'll get. In the second expression, you're going to add up the cost of everything in parentheses and subtract that from the total in the beginning, right? So keep in mind that these are equivalent because of the identity property. There is an invisible -1 here. So this -1, if you were to distribute this -1 to each piece inside here, each term, you would then flip all those pluses to minuses. And that's where this top expression kind of comes from over here. All right, so for part B, we're going to go ahead and just evaluate the algebraic expression. So what that means, we're going to go ahead and solve it, and we're going to go ahead and determine how much change you're actually going to receive here. Okay, so let's go ahead and take this expression. It doesn't really matter which one you use, but I'm going to go ahead, I guess, and use the second one here. I'm gonna go ahead and add these up all together first, and then take $20 and subtract that. All right, so let's go ahead and start writing this out. So we have the $20 that you are spending, so it's going to be 20 minus, and let's go ahead. I'm going to use brackets here just to keep this organized. Now we have 2H. That's going to be 2 of these hot chocolates. There's $3.29 each, so it's going to be 2 multiplied by the $3.29, so 2.39. And then we're going to go ahead and add the cost of B. Now B here looks like that's the large hot chocolate, and that's $4.61 each. So let's go ahead and write, we're buying 1 of those, so we don't have to write the 1 by the identity property, and that's going to be $4.61. We're going to go ahead and now add the cost of these chocolate spoons, it looks like. So this is 2E, that's the chocolate spoons, and they're $2.49 each. So we're going to do 2 times this 2.49, and then we're going to go ahead and add on this cost of the fudge, that's F here. That's 84 cents. So there's 1 of those. We don't have to write the 1 by the identity property. Let's do 0.84. Okay, so let's go ahead and write this would be the total cost of all of these pieces here. Okay, so let's go ahead, because this is an application word problem, we have a few different multiplications. We're going to go ahead and do, when I say a few, there's really only 2 here, I guess, right? But let's go ahead and multiply these out. So we have 3.29. That's for each of these regular hot chocolates. We're buying 2 of them. Let's go ahead and multiply that. So 9 times 2 is 18, carry the 1. 2 times 2 is 4, plus 1 is 5. 3 times 2 is 6. So it's going to be $6.58. And then we're buying 2 of the, looks like those chocolate spoons, right? So they're each $2.49 each, so $2.49. And we're going to multiply that by 2. So 9 times 2, that's 18, carry the 1. 2 times 4 is 8, plus 1 is 9, and then 2 times 2 is 4. So it's going to be $4.98 for those 2 chocolate spoons. So we have $20 minus, and it looks like inside here we got $6.58 plus this $4.61, plus we found out this is going to be $4.98 plus the 84 cents for the fudge at the end. So this is everything that we are buying. Now in this particular problem, it looks like we were just adding a whole bunch of these costs together, or these decimals together. So let's just go ahead and do that all at once, since it's all addition and it's commutative, so we can go ahead and do that. So we have $6.58, we have $4.61. It is important that we line up decimals when we're adding them and subtracting them. And then we have 0.84. So we have 4 decimals to add together here. Okay, so 8 plus 1 is 9, 9 plus 8 is going to be 17, 17 plus 4 is 21, put the 1, carry the 2, 2 plus 5 is 7, 7 plus 6 is 13, 13 plus 9 is 22, 22 plus 8 is going to be 30, so let's put a 0 and carry the 3. Now bring the decimal straight down, 3 plus 6 is 9, 9 plus 4 is 13, 13 plus 4 is 17, 17 plus 0 is still 17. So that's going to be 17.01 or $17.01. Okay, so it looks like when we added up all of these prices for all the food, it's going to be $17.01. So we have really $20. I'm going to write 20.00 minus the $17.01. Now, just to show this to be super clear, I know it's going to be right around $3 or $2.99, but we can go ahead and write this out as well if you're not sure. So $20 minus 17.01. What you'd have to do is just go ahead and borrow from this 2 to 1. This will become a 9, this will become a 9, and this will become a 10. So if we go ahead and subtract here, 10 minus 1 is 9, 9 minus 0 is 9, and 9 minus 7 is 2. So this does equal $2.99 when we subtract. So we go ahead and subtract here. That's going to be 2.99. Therefore, we can conclude here that the change you receive from this hot chocolate cafe is going to be $2.99. That would be our final answer. Okay, so keep in mind here, if we take a look here, this is our algebraic expression. We had 2 options here, one over here and one over here. These are both good algebraic expressions. Now, when it says evaluate the algebraic expressions, you go ahead and make some substitutions so we know our variables, what they're equal to. And so this right here is actually no longer an algebraic expression. This is just a numerical expression. So you can evaluate these numerical expressions following the order of operations. Then we can go ahead and, because these are all addition, add them all together to get this $17.01. That's the total cost of all the food. And then we can just subtract at the end here to get $2.99. So that's how much change you should receive from this hot chocolate cafe. So there you have a few different practice problems dealing with algebraic expressions. Now keep in mind that when we are evaluating these, you need to be given values for the variables, or you can make up hypothetical values if you just want to know what it could be equal to given different types of values. So obviously it could change, right? X could be another number and Y could be a different number for each of these. But in these particular practice problems, these were the values we chose to practice. So if you found this video helpful, please consider giving it a thumbs up. Keep with the great work that you're already doing, and I'll see you in the next one.